Welcome to this predicted paper from onmaths. This paper represents the best guess for the upcoming exams. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. Onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing. For us to create the largest number, we need to pick the biggest digits for the start of the number. So the biggest digit is 7, then 6, then 4, then 3. But the question says it wants the largest even number. So we need to just swap the last two around to make sure that it is even. So our answer is 7,634. Mode means most common or most frequent, and looking at this list of numbers, the number that comes up the most is this 7. All the other numbers just come up once, a 7 comes up twice. When a number is times by itself twice, we write it as 3 squared, or that number squared. When it's times by itself 3 times, we do 3 to the power of 3, or that number to the power of 3. So when we've got something times by itself 4 times, it's just going to be that number to the power of 4. One way we can convert a fraction to a percentage is we can get the bottom of the fraction to be 100. So if we write down 2 over 5, and what we can do is we can times top and bottom by 20. But let's do it by 10 first. We'll do it in 2 steps. So times that by 10, times that by 10, and then double it. So essentially we can times the whole thing by 20. So 50 times 2 is 100. Now when you have 40 over 100, percent just means per 100. So it's 40 per 100, or 40%. I'm going to start just by copying out the question. Now, when we're asked to solve, it means we need to find x, okay? And I'm going to start by putting in my solving lines, which are just lines to the left and right of the equal sign. And what we need to do is get x on its own on the left-hand side. Well, what's stopping x from being on its own? We've got this 12 here. Well, what's that 12 doing to the x? Well, it's timesing it by 12. So we need to do the opposite of that to get rid of it. What is the opposite of times 12? Divided by 12. Now these lines show us we've got to do the same to the left and right. So if I divide the left-hand side by 12, I have to divide the right-hand side by 12. So on the left-hand side we just have the x, which is what we want. On the right-hand side we do 36 divided by 12. How many 12s in 36? That would be 3. So our solution is x equals 3. So what we need to do is find out where the graph is at its highest, and so it's highest here. And so if we go down from there, we find out what year it is. Well, these years seem to be going up in 1, so that's 1950, 1951, 1952. So the answer would be 1952. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord, and the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the centre, that's a diameter. If you've got a line just going to the centre, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. So what we do is we notice that to get this 10, we add the 3 and the 7. To get this 17, we add the 7 and the 10. And to get this 27, we add the 10 and the 17. Whenever we have this kind of sequence, it's called a Fibonacci sequence. You essentially add the previous 2 terms to get to the next term. And so what we need to do is just simply add the 17 and the 27. When you do that, you get 44. So our next term is 44. I'm going to start by working out what the building is, or the width of the building is in centimetres. So it says 33 metres, and I'm going to convert that into centimetres by timesing by 100. Okay, now when it says it has a scale of 1 to 300, it means 300 in real life is 1 on our map. So all I need to do is divide it by 300 to find out what it's going to be on our map. So we'll just divide that by 300 and I get the answer of 11. So it's going to be 11 centimetres on our map. So I think about ratios as piles of money sometimes. And here we've got J getting 5 piles of money and Anne getting 4 piles of money. And each pile is going to be equal. So we've got to first of all work out how many piles of money there are. So we just add the 5 and the 4. So there's 9 piles of money. We sometimes in maths call them parts. So we say that we have 9 parts. Okay, or 9 piles of money. Now, each part, oh, I've got an equals there. Each part, or each pile, is going to be worth what 99, okay, which is the total amount of money, divided by how many equal piles we have. So divided by that 9. So 99 divided by 9 is 11. So one part is worth £11. So J has 5 piles of £11. So J has 5 times 11, which is 55. And Anne has 4 piles of that money. So 4 times 11, which is 44. We can check this by adding the two together. And it should add up to the amount of money we have, which is 99, which it does. The modal class is just the group that has the mode. Okay, the modal group. Class just means group. Now, all these guys here are groups. So any of these could be the answer. To find the modal class or the modal group, we just look to see which one has the most numbers in it. Well, the first group has 16 in it, the next group has 11, the next group 17, the next group 11, and the next group, or the last group, 13. Which of those is the most? Well, 17. So the group that has the most is this 30. Let's do that a bit nicer. 30, and then C, and then 35. That essentially means 30 to 35, but make sure you copy it down correctly from the table, so exactly as it shows it in the table. Bearings are always from north and go clockwise. So let's have a look at where the north line is. Well, the north line is here. And to find the bearing of B from A, so that means we're at A and we're looking at the angle of B, we're going to go clockwise. And you can see on the diagram it's already labelled as 42 degrees. But the third rule of bearings is they must be 3 digits. So instead of 42, it's going to be 0, 4, 2. Integer just means whole number. So we're looking for all the whole numbers that satisfy these two inequalities. Well, the first inequality says that it has to be greater than 3. So the smallest number that is greater than 3 is 4. The second inequality says it has to be less than or equal to 8. So I'm just going to keep going until I get to a number that is less than or equal to 8. It can't be 9 because 9 is not less than or equal to 8. So our answer is 4, 5, 6, 7 and 8. To find the pressure we need the area and the force. And we're given the force in the question, and so all we need to do is find out what the area is, which will be the 7 times the 9, which will be 63 centimetres squared. And the force is given to us in the question. So what we can do is write down the pressure formula, which says that pressure equals the force divided by the area. Force is given to us as 2268. The area we've calculated is 63. Divide the 2 and you get 36. So it's going to be 36 newtons per centimetre squared. The important thing to realise in this question is that we know a female has been selected. So we can just basically get rid of all of this part of the frequency tree because it's not relevant, because we know a female has been selected. So there's 29 females altogether, and we're looking for the probability that the female chosen at random picked action. So it's just simply 16 over 29. So to find the area of a rectangle, we do length times the width. So here, to find the area, we will do the 10 times the whole of the 10t plus 4. And to show that we're doing the whole of it, we put it in brackets. So a different way of writing that is 10 brackets 10t plus 4. And whichever method you use to expand brackets, feel free to do it here. I'm going to just do the grid method, but whatever method you prefer. Actually, I don't need the, I've done too many here. Let's get rid of that. So we've got 10 times 10t plus 4. So and we're timesing them, so 10 times 10t, 10 times 10 is 100, so it'd be 100t, 10 times 4 is 40. So our answer will be 100t plus 40. So we know that 171 is 3 times 3 times 19. And what we do is we just compare 171 with 342. And we know that 171 times 2 is 342. So therefore 342 will have the same prime factors as 171, which is 3 times 3 times 19, but it will also have a times 2 in there. So the answer will be 2 times 3 times 3 times 19. To convert from meters to centimeters, we times by 100. But here we're asked to convert between meters cubed and centimeters cubed. So we times it by 100 per dimension. Meters cubed and centimeters cubed is volume, which is 3 dimensions. So what we do is we times it by 100 3 times, times 100, times 100, times 100, or times by 100 cubed. So we get our amount, 0.15, times it by 100 cubed, and that will give us 150,000. So our answer is 150,000 centimeters cubed. So to find the locus of points that are 10 centimeters away from a point, you need to measure 10 centimeters on a pair of compasses, and then you put the point at A and draw them. Now I'm going to try my best to do this. It's probably not going to look perfect, but I'll do my best. And the length here, which is supposed to be, probably isn't exactly, but this part here is going to be 10 centimeters to get the full marks, and obviously you want the circle to be a little bit nicer than the one I've drawn, but try and get it as perfect as you can. And the best way of doing that is just don't push down too much and just move the page around with your compass being stationary. The word truncated means that we just literally cut off the next number along. So if we imagine this is our number, we just cut it off. So it's not the same as rounding. We just don't change this digit at all. We just cut off the remaining digits. So the smallest number it could be before it was cut off is 79.500000. The largest number it could have been, well, it could have been 79.5999, etc. So that's the largest it could have been. So to do our error interval, well, the smallest it could have been is 79.5, and it could have been 79.5, and we'll call this x. But we're looking at any number that is less than 79.6. So any number that's less than 79.6. If it was 79.6, then when we cut it off, it would show as 79.6. So the way this formula works is we have m, which is the final amount. The 2000 here is our initial amount. The decimal in here is our multiplier, and the power here is the amount of years. So the way multipliers work is they are the percentage divided by 100. So if we go the other way and times it by 100 to make it back into a percentage, it will be 102.9%. Now it says, what is the interest rate of the bank? Well, the interest rate is always going to be 100%, well, this 102.9% is 100% plus the interest rate, which will equal the 102.9%. So the interest rate is going to be the 2.9%. You always start off with 100%. So if I put £5 into my bank, I've got 100% of that £5, and then the interest rate is on top of that 100%. So our answer here will be 2.9%. The first thing that we can actually work out for this Venn diagram is this part here. So it says 12 had a cat but not a dog. So the cat but not a dog is showed with this A here. So if 12 had a cat but not a dog, and in total 22 had a cat, we're going to do 22 take away 12, which is 10. So 10 had a cat and a dog. If 16 had a dog, and 10 also had a cat, that means that 6 had a dog. Let's make sure we fill these in. And if overall there were 31 people, and there were 12 who just had a cat, 10 who had a cat and a dog, and 6 who had a dog, that leaves 3 left over. When we multiply numbers, it doesn't actually matter which order we multiply them. So I can actually rewrite this as 7 times 9 times 10 to the power of 2 times 10 to the power of 9. 7 times 9 is 63. And 10 to the power of 2 times 10 to the power of 9, we add the powers, so it'd be 10 to the power of 11. Now here we've got a problem. It looks like standard form, but it is not standard form. Because standard form has to be a number between 1 and 10, but not including 10. And here we've got 63. So what I'm going to do is just quickly write out what number this is. So we've got the decimal point here. And you don't need to do this, but I find it a bit easier to show what we're doing. So here we've got 10 to the power of 11. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We fill these all out with zeros. And that's the number we've created here. A lot of zeros. Now, to make it a number between 1 and 10, not including 10, the decimal point, it needs to be here. So we want that to end up with 6.3 times 10 to the power of, well, let's work that out now. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 10 to the power of 12. Now you don't need to do all the working out I've just shown there. You just need to know when you convert that 63 into a 6.3, you need to add 1 to the power. When it's said that y is inversely proportional to x, it means that y changes as 1 over x changes. And to write this in an equation, all we do is we just write y equals k over x. Now k is something we need to find. So what we need to do is find out what a value of y and a value of x are somewhere on the graph that would be formed from this, and we've got that in this question. So we know that when y is 7, then x is going to be 7.9. And what I need to do now is just draw my lines down. And what I'm going to do is I'm going to just times both sides by 7.9. And so we have k equals, and it'd be 7 times 7.9, which is 55.3. So we know that k is 55.3. So I'm just going to rewrite this equation here, or this formula here. But instead of k, I know that it's going to be 55.3. So our answer is y equals 55.3 over x. There's two parts to this power. I'm just going to do it a bit bigger so we can see. We've got the negative here, and the negative will mean that we will find the reciprocal. And we've got this 3 here, which is just what the power will be. So, how do we find the reciprocal? Well, if you think about the number 10, if you had to write that as a fraction, you would write it as 10 over 1. And so to find the reciprocal of it, we're just going to flip that fraction. So this will now become 1 over 10. We haven't dealt with that cube yet. So we're going to cube top and bottom with that fraction. Well, it's not going to do anything to the top because 1 cubed is just 1. But the bottom will turn into 1,000. So it's going to be 1 over 1,000. So we've got to get the left-hand side factorised. So we put down 2 sets of brackets. And we're looking for 2 numbers that multiply together to make that 24, and add together to make the 14. And we're going to have an x at the start of each of those brackets. So 24 would be 12 and 2 would add together to make 14. So plus 12 plus 2. And to solve, we get the left-hand bracket equal to 0. And we get our solving lines in. So minus 12 both sides. And you get x equals minus 12. So that's one of our solutions. And we do exactly the same thing with the other bracket. Get it equal to 0. And solve. So we're going to take away 2 from both sides to get x on its own. So x equals minus 2. So our solutions are 12 and minus 2. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions, and mini mocks. If you like what we do, please consider subscribing.